Okay. So, we are back again, right. So, now if you look into, if you look now that your what you call that your deregulated environment, then each entity, this is a generation company, it has one generator, say it has two generators, it has two generators, and this is all independent power producer also. There is we call it is a GENCO, and this is also we call GENCO, and this transmission company we call TRANSCO, and distribution company we call DISCO, right. So, now we have earlier it was together, now it is a three different entity: generation, transmission and distribution, right. So, this is the concept for deregulated thing. So, that is deregulated utility structures. Now, it is separated, that was vertically integrated utility, now it is separated, right. Now, with the emergence of the distinct identities of GENCOs, TRANSCOs, DISCOs, and ISO means independent system or independent system operators, right. So, in there you have to, I mean this ISO, that many of the ancillary services of vertical integrated utility will have a different role to play, and hence have to be modeled differently, right. So, not only AGC, there may be other ancillary services, right. So, among those among these ancillary services is the automatic generation control. So, in the new scenario, a DISCO can contact individually with a GENCO for power, and their transaction will be made under the supervision of ISO, right. Now, traditional versus your restructured scenario. So, in the previous section we have seen the vertically integrated utility structure and deregulated utility structure have been discussed, right. And there are several GENCOs and DISCOs in the deregulated structure. So, a DISCO has the freedom to have a contact with any GENCO, right, for transaction of power. So, a DISCO may have a contact with a GENCO in another control area, that I told you. Suppose there are two areas A and B. In the area A, some distribution companies are there, generation companies are also there. In the area B also some distribution company and generation companies are there, they are connected by tie lines, right. So, if power is cheaper, then DISCO has every right to buy power not from its own area, but from other areas too, because if it finds that power energy purchase is cheaper, right. So, such transactions are called bilateral transactions, right. All the transactions have to be cleared through an impartial entity called independent system operator, right. So, I told you that independent system operator, it is a separate entity, separate office, all GENCOs, all bidding will take place there only, right. The ISO has to control a number of so called ancillary services, one of which is AGC, right. So, to realize this, mathematically to realize this, so what we will see that DISCO, we call a term that DISCO participation matrix, in short we call DPM, right. So, in the restructure the DPM little bit we have to understand, just see how it is very simple, that in the restructured environment GENCOs sell power to various DISCOs, right, at competitive prices. Thus, DISCOs have the liberty to choose the GENCOs, right, for contacts. They may or may not have contacts with the GENCOs in their own area. This makes various combination of GENCO DISCO contact possible in practice, right. So, we will describe the DISCO participation matrix, that is DPM, right, to make the visualization of contacts easier. Actually DPM is a matrix with the number of rows equal to the number of GENCOs and the number of columns equal to the number of DISCOs in the system. For the purpose of explanation, just consider a two area system in which each area has two GENCOs and two DISCOs, right. Let GENCO 1, GENCO 2, DISCO 1, DISCO 2 are in area 1 and GENCO 3, GENCO 4, DISCO 3, DISCO 4 are in area 2 as shown in figure 3. Now, let us try to understand this. Although it looks like simple, but some understanding is required. Suppose this is my area 1 and this is my area 2. So, in area 1 two GENCOs are there, two DISCOs are there, does not mean anything. It may be 2 GENCOs, 4 DISCOs or 4 GENCO, 2 DISCOs, it is like that only, right. Just for the sake of explanation we have taken like this, and these two areas are interconnected by tie line. Say power is flowing from, say this is my area 1 and this is area 2. So, power is flowing from 1 to 2. So, this power is delta P tie 1 2, right, and area 2, two GENCOs are there, GENCO 3, GENCO 4, and 2 DISCOs are there, DISCO 3 and DISCO 4, right? Distribution company is 3 and distribution company 4. Now, this and another independent system operator is there, right. So, we call ISO. So, all bidding will be done. Suppose these distribution companies, they have the right, if they find if I buy power from this area, that is from GENCO 3 or GENCO 4, then your what we call it will be cheaper, then it cannot buy power from GENCO 1 or GENCO 2. Similarly, for DISCO 3 and DISCO 4, if it finds your power is energy purchase is cheaper from GENCO 1 or GENCO 2, then these two also can buy power from GENCO 1 and GENCO 2. At the same time, if they find that I can buy power, we can buy power, DISCO 1, DISCO 2 can think that we can buy power from GENCO 1 partly, GENCO 1 from GENCO 2, partly from GENCO 3 and GENCO 4, that is also possible. Similarly, for DISCO 3 and DISCO 4, they can also purchase power from GENCO 3 or GENCO 4 or from GENCO 1 and GENCO 2, right, and that power will be power wheeling will take place through the tie line. So, these are the certain things. For this case, we are not considering any losses or anything, right, those are beyond the scope for this course, right, this is a control type of thing. So, that's why this 2 area system is taken. Now, question is that how to, based on that, how to form your what you call that your DPM, that is DISCO participation matrix, right. So, DISCO participation matrix is, suppose I told you that this horizontal one, that DISCO 1, DISCO 2, DISCO 3, DISCO 4, the meaning is like this, and this is, and this vertical one is GENCO 1, GENCO 2, GENCO 3, GENCO 4. And accordingly, this matrix is not n into n matrix like this, nothing like this. You have to see how many GENCOs and how many DISCOs are there. So, accordingly the this matrix order will be, right, but here 2 each. So, that is why it is becoming 4 into 4. So, but you have to order like this. Suppose you have, in area 1 you have one more say one more DISCOs, then DISCO 1, DISCO 2, DISCO 3 will come, then DISCO 4, DISCO 5, DISCO 6 will come for area 2. Suppose if it is like this, or if DISCO 1, DISCO 2, DISCO 3, 3 distribution companies are there in area 1, so 3 will be there, and then DISCO 4, DISCO 5 will be there. So, accordingly you have to take. Now, suppose this is distribution company, right. Now, suppose for example, I have taken one example later. Suppose DISCO 1, this CPF 1 and this CPF, this matrix element in general CPF, this is called contract participation factor, that is written there, that is contract participation factor, right. So, contract participation factor. So, in this case CPF, so these values are less than 1, right, these values are less than 1. Suppose the DISCO 1 has some DISCO 1 say it may total demand maybe say 10 megawatt. So, part of that it can borrow from GENCO 1, it can GENCO 1, DISCO from GENCO 2, GENCO 3 and GENCO 4. Suppose my DISCO 1, right, DISCO 1, the distribution company is 1, its total power demand is 10 megawatt, say 10 megawatt, right. So, now it needs from GENCO 1, say GENCO 1, DISCO 1 it needs say 2 megawatt, say GENCO 2 it needs 3 megawatt, right. So, here it needs 4 megawatt and for GENCO 4 it needs 1 megawatt, right. So, DISCO 1 needs 2 megawatt from your GENCO 1, DISCO 1 needs 3 megawatt from GENCO 2, DISCO 1 needs 4 megawatt from GENCO 3 and DISCO 1 needs 1 megawatt from GENCO 4, say, right. Total is 10, then what will be CPF 11? CPF 11, right. Say total is 10 megawatt. So, denominator will be 10 and it needs 2 megawatt from GENCO 1. So, 2 by 10 that will be your 0.2, right. Similarly, CPF 21 because DISCO 1 needs 3 megawatt from GENCO 2, right. So, it will be your CPF 21 it will be your 3 by 10 that is your 0.3, right. Similarly, your this 4 megawatt that DISCO 1 needs from GENCO 3, that means my CPF your 31 is equal to 4 by 10 that is 0.4, right. Similarly, CPF 41 because DISCO 1 needs 1 megawatt from your GENCO 4. So, CPF 41 is equal to 1 by 10 that is 0.1. That means, CPF 11 is 0.2, look CPF 11 is 0.2, CPF 21 is 0.3 say plus 0.3 you add all, then CPF 31 is 0.4 here, plus you add 0.4 plus CPF 41, right, your CPF 31, CPF 21, CPF 31, CPF 41 is 0.1. If you add all this, it is actually 1.0, right, 1.0. That means it is a fraction only. That means I have to put the fraction of that, how much I need, right. So, it is 2 megawatt means total is 10, out of which 2 is taking. So, its fraction will be that this matrix will be then, this column matrix will be then, it will be your 0.2, then your this one is taking 3. So, 0.3, 0.4 and 0.1, right. So, that is the meaning of your for DISCO 1. That means, this column your elements, you if you add all, it will be 1. That means for all the cases, for first column CPF 11, CPF 21 plus CPF 31 plus CPF 41 is equal to 1.0. Column wise it should be 1.0. Similarly, if you add all, it has to be 1.0. Column wise 1.0, column wise 1.0, right. So, that means this is the idea. This is the idea for your this DISCO participation matrix. Similarly, say this is DISCO 3, right. It is possible that there cannot be, or what you call, suppose DISCO 1 has 10 megawatt, right, DISCO, but it does not want anything from GENCO 1. So, it will be 0.0. It does not want anything from GENCO 2, it will be 0.0. Suppose it wants 4 megawatt from here and 6 megawatt from here. So, that means this value will be 0.4 and this value will be 0.6, this is 0.0, this is 0.0, you add all, it will be 1.0, right. So, that is your what you call the concept of DISCO participation matrix, right. So, I hope you have understood this part, right. So, that after that everything whatever I have explained, that after that everything is written. So, can be thought of as a fraction of total your load contacted by DISCO, I told you, toward the GENCOs, right. So, thus that is ith entry correspond to the fraction of the total load power contacted by DISCO J from a GENCO I in general, but I told you what exactly it is, right. The sum of the entries in a column in this matrix is unity, that also I told you. So, DPM shows, that is DISCO participation matrix shows the participation of a DISCO in a contract with a GENCO and hence the DISCO participation matrix. That is why its name is DISCO participation matrix, right. So, the DISCO, that is the DPM shows the participation of DISCO in a contract with a GENCO and hence this name is DISCO participation matrix, right. So, in equation 1, CPIJ, that is your CPF ij, contract participation factor CPF ij refers to contract participation factor, right. So, again I have taken another whatever example I have given. For another example, that for the purpose of explanation, suppose that DISCO 2 demands 0.1 per unit megawatt power, right. Total is 0.1 per unit, out of which 0.02 per megawatt per unit megawatt is demanded from GENCO 1, 0.035 per unit megawatt demanded from GENCO 2, 0.025 per unit megawatt demanded from GENCO 3 and 0.02 per unit megawatt demanded from GENCO 4, right. Therefore, the column 2 entries, one column I showed you, this another one, that CPF 12, right, will be your 0.02 upon 0.1. So, 0.2, CPF 22 will be 0.035 upon 0.1, because 0.1 per unit megawatt is the total demand, is equal to 0.35, CPF 32 is equal to 0.025 upon 0.1. So, 0.25 and CPF 42 is equal to 0.02 upon 0.1. So, 0.2. Now, if you add all the column wise CPF 12, that is second column, CPF 12, CPF 22 plus CPF 32 plus CPF 40, if you add all, it is 1.0. That means, this column, this second column 12, CPF 12 plus CPF 22 plus CPF 32 plus CPF 42, if you add all, that it has to be your 1, right. So, in general for all I, CPF ij will be 1.0, right. So, column wise it will be 1.0, right. So, next is the block diagram representation of AGC in deregulated environment. So, block diagram representation of a two area system has been presented, we have seen for conventional AGC. Here we will formulate the block diagram for a 2-area AGC system in the deregulated scenario. Whenever a load demanded by DISCO changes, it is reflected as a local load in the area to which the DISCO belongs, right. This corresponds to the local loads del PL1 and delta PL2, because the delta PL1, that is the total load demanded by DISCO 1, and delta PL2 total load demanded by DISCO 2. So, this can be considered as local load and it will be reflected in area 1 and should be reflected in the deregulated AGC block diagram at the point of input to the power system block, right. This we will see, as there are many GENCOs in each areas, AC signal has to be distributed among them in proportion to their participation AGC, that also we will see. Little bit we have seen in conventional AGC, that AC participation factor. Coefficient that distribute AC to several GENCOs are termed as AC participation factor, right. So, as long as in the system there is no uncontacted power demand, we will come to that later. Suppose DISCO distribution companies have some contacted power with all the generation companies. Apart from that, if that distribution companies need some extra power which was not in contact, right, that is called uncontacted power demand, right. At that time AC participation factor will play a significant role. Otherwise, if no uncontacted power demand is there, then this AC participation factor has its effects on transient, but not at the steady state, that we will see, right. So, note that your this is AJI dash, actually this is actually called that AC participation factor, that we will see later, it is NGENCO J, right. So, AJI dash is participation factor of I GENCO in jth area, and we are putting AJI dash, and NGENCO J is number of GENCOs in jth area, right. Suppose in area 1, suppose you have 2 GENCOs, so it will be I is equal to 1 to 2, right, and J is a I GENCO in the jth area, right. So, it will be I mean it is something like this. For this same example, suppose that I GENCO in jth area, suppose jth area means suppose area is equal to 1, J is equal to 1, right, and your what you call that number of GENCOs in jth area, suppose that is I, suppose I is equal to 2 GENCOs are there. For area 1 we have seen 2 GENCOs to DISCO. So, basically this will be is equal to 2, right. That means this one actually will be your J is equal to 1. So, it will be A dash 1 1 plus A dash 1 2 is equal to 1.0. This is the meaning, right. So, unlike the traditional AC system, a distribution company, that is DISCO, asks or demands a particular GENCO or GENCOs, right, for load power. These demands must be reflected in the demands of the your what you call this must be reflected in the dynamics of the system, right, because of the load demand, that when you consider dynamics, right, the transient behavior will change. So, turbine and governor units must respond to this power demand, right, because this signal will go to the set point of that. So, whatever power demand is coming, that we will see those things, right, and thus as a particular set of GENCOs are supposed to follow the load demanded by a DISCO. When GENCO is following this load, what is demanded by DISCOs, in other term we call load following, right. Information signals must flow from a DISCO to a particular GENCO. That means you have a better, for deregulated system you have a better communication channel, right. So, that means this, otherwise how this information will reach to that, right, must flow from a DISCO to a particular GENCO specifying corresponding demands, right. The demands and are specified by contacts participation factors, that is your elements of DISCO participation matrix DPM, and the per unit megawatt load of a DISCO. These signals carry information as to how which GENCO has to follow a load demanded by which DISCO, right. So, this signal will go accordingly, generator, that is GENCOs will generate the power, that means GENCOs will follow the load, right, of the load demand of the DISCOs. In other name is load following. steady state now in this case what will happen, the scheduled steady state power flow on the tie line is given us. So, before going to that we will go back to that diagram again, right. So, in this case this two area this thing, right. So, in this case that it is area 1 and it is area 1 and it is area 2. So, in this power is flowing, say we have taken the direction say 1 to 2, if 1 to delta p tie want to become negative means it is flowing from 2 to 1. So, if when is taking 1 to 2, so how we will do this? I mean how we will find out that delta p tie want to schedule power flow when all the demanded load demanded by DISCOs are known. Then what will happen, that you have DISCO 3 and DISCO 4 in area 2, right. So, what we will do is that first you will take that what is the power demand of DISCO 3 and DISCO 4, that whatever contact they have with this one and with this one, right. I mean whatever they have. So, that means DISCO 3 and DISCO 4 will take power from GENCO 1 and GENCO 2, whatever contact CPF they have, right. So, that means this power, if DISCO 3 DISCO 4 takes power from GENCO 1 and GENCO 2, so this power will be flowing in this direction, right. And similarly, DISCO 1 and DISCO 2 whatever will there, whatever they will take from GENCO 3 and GENCO 4, this their power will try to flow in this direction. So, ultimately resultant will be that this power whatever DISCO 3 and DISCO 4 is drawing minus your this power demanded by DISCO 1 and DISCO 2 which they have contact with GENCO 3 and GENCO 4. So, that means first you have to consider that whatever DISCO 3 and DISCO 3 your distribution companies 3 and 4 have contact with GENCO 1 and GENCO 2, that you take first. So, that will be the first thing, minus your whatever DISCO, because this power is flowing in this direction, right. But our objective is in this direction, but this power DISCO 1 DISCO 2's power flowing in this direction. So, this direction. So, resultant will be this power minus their power demand by this one, right. So, that is the idea, that delta p tie 1 2. So, mathematically we can represent like this. So, mathematically we can make it like this, that delta p tie 1 2, this is a scheduled type power flow, right. So, demand of DISCOs in area 2 I told you from GENCOs in area 1 minus demand of DISCOs in area 1 from GENCOs in area 2, because we have taken direction 1 to 2. That is why demand of DISCOs in area 2 from your 1. So, power is flowing 1 to 2 minus demand, because minus taking because its power is flowing from 2 to 1, because DISCOs area 1 demanding power from your GENCOs in area 2. So, we have only 2 DISCOs and 2 GENCOs, right. So, I is equal to 1 sigma I is equal to 1 to 2 and j is equal to 3 to 4 CPF ij delta PLJ, right, minus your I is equal to 3 to 4, then j is equal to 1 to 2, that CPF ij delta PLJ. So, if you look into this, right. So, DISCO 3 and DISCO 4, this is demanding power from, I mean in the area 2 you have DISCO 3 and DISCO 4, 2 distribution companies, and area, this is your area 2, and area 1 you have GENCO 1 and GENCO 2, right. So, that means you have your GENCO DISCO 3 and DISCO 4 is area your 2. So, sigma j is equal to 3 to 4 CPF ij delta PLJ, and GENCOs, there are 2 GENCOs I is equal to 1 to 2, that is why you have taken. Similarly, in that your what you call that in area your what you call that your demand of DISCOs in area 1. In area 1 there are your 2 DISCOs, right. So, that is your j is equal to 1 to 2, right. So, this is for DISCOs, and you have 2 GENCOs, that is in your area 2. So, that is I is equal to 3 to 4. So, this is this way, the mathematically this way you can write, right. So, this is my your what you call the schedule power, total schedule power. Now, now if you so mathematically, just hold on. So, that means mathematically, if you expand this one, so I am making it here that this is actually delta p I want to schedule, right, is equal to that if you put when I is equal to 1, j is equal to 3 to 4, right. When I is equal to 1, that means CPF, right, I is equal to 1, that 1 3 delta PL3, right, plus CPF 1 4, right, your j is equal to 4, then delta PL4, this is for I is equal to 1, then plus your when I is equal to 2, CPF 2, then 3 your delta PL3 plus CPF 2 4 delta PL4, right. Whenever I am writing all this, please check yourself, right. Hope I am not making any error or mistake, but for expansion another thing, be careful, because it is a video recording, once it is missed, then it will remain as it is. So, you should correct it. By chance if you find any error or anything, please let me know. Then this is minus. So, when I is equal to 3, j is equal to 1 to 3. So, CPF, right, your what you call that I is equal to 3. So, CPF 3 1, your delta PL 1, right, then your plus your CPF 3 2 delta PL 2 plus, then when I is equal to 4, CPF 4 1 delta PL 1 plus CPF 4 2 delta PL 2, right. So, if you expand this, it will be like this. So, that means your that delta p ti error will be then that actual power flow minus delta p ti 1 to schedule power flow. This actual tie line power flow later we will see, right, that it will come from the your mathematical model, what is the actual, what is the schedule, but at steady state we want this one should be is equal to 0. If this one is equal to 0, then actual power flow will be is equal to your schedule power flow at the steady state, right. So, thank you very much. We will be coming more about this thing in the next video lecture. Thank you.